We are back, my friends. This is part 2 of the proteins chapter for Bio 125 Nutrition. In the first video, we talked about the structure of protein, the functions of protein, specifics about what's unique about protein digestion and absorption. And then we ended the first video by talking about what happens to protein after it's absorbed. Be sure to go over that. Okay, so we pick things up here. We want to talk about a little bit about how the body makes protein. Wait a minute, didn't we already say we have those non-essential amino acids? We sure do. So out of the 20 amino acids total, our body is able to make 11 of them. And that means because our body can make them, it is not essential that we get them through the diet. So, of course, our body makes protein. In the first video, I alluded to the fact that our cells are little protein-producing factories. Very cool. So, that process, by the way, is called protein synthesis. And you can see a little picture of a factory there. Indeed, our cells, muscle cells, liver cells, kidney cells, you name it. Pretty much every cell in the body is making protein. That is amazing. Just know the name of it, protein synthesis. We're not going to get into the specifics of all the chemistry behind that. Suffice it to say that the process of how our cells make protein is called protein synthesis. I want to talk a little bit about some of it. And let me just give you a little bit of a background for those who are interested. So let's just take our everyday animal cell. We have the nucleus, and then we have something outside of it. Let me go back to the blue. Something outside of it called the endoplasmic reticulum. Let me do red. Over here, let's see, we have the Golgi apparatus, looks like that. And we have these really important structures. What color? Okay, let's use purple. We have these really important structures called ribosomes. Some of them are attached to the ER. Some of them are free floating. You do not have to know any of this. I'm just giving you some extra information if you're interested. Well, inside the nucleus, we have the DNA, right? And the DNA is kind of like the instruction manual. So all I want to say here, let me just go ahead to one screen. Yes. So all I want to point out here is that the DNA hold the directions or the instructions. So it's almost like the DNA houses the instruction manual. You know, if you order something, particularly, if anybody knows, if you order something from IKEA, you order like a dresser or a table or pretty much anything. It comes in a box, and then it comes with these long directions. Well, the directions would act like the DNA of a cell because the DNA contains the instructions. But in this case, it's the instruction manual that tells the cell what kind of protein to make. Now, I'm really simplifying it, but this is the gist of it. The DNA is like an instruction manual. In the case of the cell, that instruction manual is telling the cell what kind of proteins to make. This is all I want to get across to you. If we go back to this picture, the DNA has the instruction manual. And the DNA tells the ribosomes what kind of proteins to make. Then those ribosomes go on to make proteins. We'll call them pro. So based on the instructions from the DNA, these ribosomes make proteins. I can spell it out. And then those proteins go on to leave the cell and do their job. Maybe it's a protein designed to make muscle tissue. Maybe it's a protein designed to make up the structure of an enzyme. But the key is that these proteins are made based on the instructions from the DNA. All the rest here is extra. Here's a way better picture of what I said. This has a lot more information than you need to know. I just want to point out that, we know that the DNA holds the genetic code, quote unquote. Well, that genetic code is really kind of a set of instructions, and the way that it's expressed, these instructions or this genetic code, is by telling the cell what kind of proteins to make. There can be problems in this process. You do not need to know this. One example of when this process goes wrong is when the body, instead of making a nice normal red blood cell should look like this. That kind of donut shape, so it might look like that. Instead of making a red blood cell that looks normal, the instructions are messed up, and it makes a sickled cell. It's like a sickle shape. And of course, when the protein is not its correct shape, it's not able to do its job. So in this case, the hemoglobin can no longer transport oxygen. You don't need to know this. And I'm just making the point again. The proteins that are made based off of the instructions from the DNA in the nucleus go on to do all those functions that we talked about. Structure, forming chemicals, all those lovely things. Okay, so this process is really important. We're constantly producing new proteins. And then as we talked about in the amino acid pool, old amino acids are broken down or amino acids are used up by the tissues. We've got to replace them with new. Well, this is a delicate balance. Because we can't really store very much protein, we can only store it in these little protein amino acid pools, these little collections that travel around the blood. Because we can't store it, we can't make a whole lot extra. So our body has to regulate this very closely. Your body has to be able to know how many proteins to make to meet the need of the body. The goal of protein synthesis is to make protein, make enough protein to meet the demands of what's been broken down. In other words, the body wants to create, how can I say this? Create same amount of protein that's been broken down. Protein used by body or broken down. So in other words, your body wants to create the same amount as what has been used or broken down. So it's an even, level playing field. We don't want to create too much, more than we need, because then we don't have to. Then we can't store it. It's hard to get rid of. Might get stored as fat. And we don't want to create less, because then we're not satisfying and refilling all those amino acid pools that we need to. One way that we can assess this is through nitrogen levels. And we're going to consider this to be nitrogen balance. Because proteins are made up of nitrogen, right? That was something unique. Carbs and lipids are not made up of nitrogen. Our nitrogen creation must equal our nitrogen use or breakdown. Because they're really one and the same. Proteins are made up of nitrogen. So we can just simply take a measure of nitrogen in the body. And we can do blood tests for this. We can measure nitrogen. Particularly, we can measure the breakdown products of nitrogen in the urine to get a sense of whether we are producing enough nitrogen and or proteins to meet the nitrogen use or protein use. And this is how our body regulates it. If all of a sudden the kidneys notice, hey, wait, there's a lot of nitrogen breakdown. Well, maybe there's too much protein, and that'll signal to the brain to tell the cells make less protein. On the other hand, if the kidneys notice, hey, wait, there's no protein breakdown products, that probably means that we need more. So the kidneys will tell the brain to tell the cells to make more protein. You don't need to know all that specifics. Just know that we're going to know two things. We want to create the same amount of protein and or nitrogen to equal the amount that we use or break down. And we can measure how well we're doing that based off of our nitrogen levels. And we call this nitrogen balance. I like this picture. It's kind of simple, but it gets the point across. You want to be in equilibrium. Our goal is to be here. We are bringing in the same amount of protein as we excrete. It's equal. So we have the same size arrow protein coming in and the same size arrow protein leaving, because the amounts of protein that we bring in are equal to the amount that we've broken down or used. Positive nitrogen balance means that your protein intake is greater than your excretion. That's why the arrow here on the left is big versus a smaller arrow on this side. Sometimes this is normal. Sometimes it's normal for a pregnant woman. What about an athlete in training who's breaking down a lot of protein? Know these two examples. So sometimes a positive nitrogen balance is normal because we're excreting more protein or because we're supporting a baby, right? So there's certain instances when a positive protein or nitrogen balance is normal. But for an everyday person, for a healthy adult, it wouldn't be normal. And you would be at risk for bringing in too much protein, which can stress your kidneys, which can lead to storage as fat. On the other hand, there can be a negative protein or nitrogen balance, where your intake is less than your excretion. So you're excreting more. You're excreting a whole bunch and not bringing in enough. This is not good, folks. Someone is starving themselves or in a part of the world or country where they don't have access or cannot get enough food. Or it could mean illness and injury, right? So you don't want to be in negative nitrogen balance where your body is breaking down a whole lot of proteins and it can't bring in enough to equal it out. Make sure you know this. So here it's kind of in picture form. Here it's written in word form. Good stuff. Okay, let's talk about dietary requirements. I'm from Maryland. There you go. We already know that about 10 to 35% of the daily diet should come from protein. We know that. That's the AMDR. Now, here's a case where I'm actually going to give you a number, and we haven't done this yet. Even though I've given you examples, particularly with the carbohydrates, I've given you examples of how many carbs maybe an adult male or female can bring in. But I didn't give you a number to memorize, but here I am. So you should know for a sedentary adult, sedentary means not active, not actively training, physical activity, not an athlete. The person should bring in 0.8 grams of protein per kilogram of body weight. So here we can be a little bit more specific. You should know this number, 0.8 grams of protein per kilogram of body weight. We can do this ourselves, right? So if you want to figure this out, I'm not going to ask you to do it for a test, but you might want to do it just for fun. Take your weight and divide by 2.2 to get your weight in kilograms. Someone who's 130 pounds, divide by 2.2, they're 59 kilograms. Then you take that kilogram, whatever it was, here it was 59 kilograms, multiply it by 0.8. This person would need about 47 grams of protein per day. So the nice thing about this recommendation is that it's given based on your weight. So a 130-pound person is maybe going to need 47 grams, but a 260-pound person would need twice that much. It makes sense. The bigger you are, the more protein your body is going to need because you have more to your body. Okay? Now, that's a pretty lightweight person, 130 pounds, right? But I just am giving you some examples. It's not really difficult to meet. 5 ounces of steak and 1 cup of cheesy, delicious potatoes, 47 grams of protein. So it's pretty easy to meet these. As part of your critical thinking assignments, as you know, I'm asking you to go to MyFitnessPal and you're putting in your diet and you can see, right? Are you meeting your goal? And folks, remember, you may not meet it every day, but we would prefer to look over the course of weeks and months. Over the course of weeks and months, on average, are you meeting your requirements or are you over or below? Some days you're going to be higher, some days you're going to be lower. Now, before we go on, I do want to go back to this 0.8 number. Remember, this is a number for an adult who is sedentary, not doing any extra activity. If you are an athlete, if you are someone who is on your feet all day, well, this number is going to go up a little bit. You don't have to know these that I'm about to talk about, but I just want to give you an idea. So maybe an athlete, 1.0 grams per kilogram, 1.2, 1.4. So it goes up a little, but it doesn't go up as much as you might think. I mean, you know, I teach sports nutrition. I'm an athlete myself. I've been dealing with athletes for 20 years. The highest I've ever seen might be 2.2, and that would be an Olympic level weightlifter. So of course, athletes need a little more, but it may not be as much as you think. Okay. So just like we talked about with carbohydrates, there is an issue of quality. We talked about carbohydrates, you know, quote unquote good versus bad. It's better to have more carbohydrates that are whole grain, that use the whole part of the grain. It's better to have less of the added sugar type of carbohydrates, understanding that you're probably going to have a little bit of both. So in a similar yet different way, we can talk about the quality of proteins. And it's not all about, I'm trying to think about how to say this. Bear with me here. I apologize. It's not just all about its nutritional benefit. It's also about its digestibility. Because indeed, protein is hard to work with. So when we talk about protein quality, let's first start with amino acid composition. And if I go back, that's this one. So a good protein, a quote-unquote good protein source, is going to supply more amino acids. So quote-unquote good proteins, and again, I'm using this term loosely. Instead of saying supply, let me say contain. I think that'd be better. Quote-unquote good proteins contain more amino acids. So a complete protein, for example, gives you all 9 of the essential amino acids. Incomplete, which may not be as quote-unquote good protein, doesn't give you all the essential amino acids. So you don't need to only be ingesting complete proteins, but I think the key is eating a variety of foods. Because ultimately, the goal is to get all essential amino acids. And It might take a little bit of work for some people, but it's not that hard with all the food that we have out there. So the best thing to do is to eat a variety of foods. And that way, even if some of the individual proteins aren't complete, in total, you will be getting all of the essential amino acids. Let me just go ahead once. Yeah, so I give you some examples here. Complete proteins, there's actually more than you think. There's a lot of particularly animal proteins that do have all 9 essential amino acids. Fish, even soy products like tofu. Incomplete proteins do not have all 9 essential amino acids. Sometimes there's a limiting amino acid, but don't worry about that. I just gave you some examples here. But one part of considering protein quality is how many of those essential amino acids does it contain? A quote-unquote better protein or a complete protein has all of them, all 9 essential amino acids. A quote-unquote incomplete protein, or what some might say is poorer choice protein, doesn't have all 9 essential amino acids. But that's okay. If you're eating a variety of foods, you should not have a problem getting all 9 essential amino acids. So that was one thing to consider. Amino acid composition. We should also be considering digestibility. And this is something that is unique to protein. We really don't have to concern ourselves as much with digestibility of lipids and carbs. But with protein, we do. And what happens is animal proteins tend to be absorbed more easily versus vegetable proteins are not absorbed as easily. They're still absorbed really well, meaning the majority of what we bring in is able to be absorbed from a vegetable source. But animals will give us the best digestibility and absorptibility. You don't need to know these numbers, but just know that animal proteins we can absorb better. That doesn't mean that vegetable proteins are bad. What it does mean is if you are vegetarian, like I am, you just have to get a variety of vegetable sources to make sure that we are getting in enough protein to absorb enough to meet our needs. All right, good stuff, my friends. So I gave you an example of getting our complete and incomplete proteins. But let's also talk about vegetables. We can also get a lot of protein from vegetables. Oh, let me go back here. You can see I included some things. They tend to be more incomplete: peanut butter, beans, chickpeas. But I'm just saying you can get some protein from vegetables. Yes, my friends. All right, other considerations. So we talked about the protein quality, talking about how many essential amino acids does it offer us, and is it digested and absorbed well? Other things to consider. When we talk about protein, particularly animal sources, so I'm focusing a lot on animal sources, hence these pictures, right? I just kind of like the fried chicken picture. It's cute. Even though I don't eat it, it's cute. When we talk about animal sources in particular, in addition to the protein quality, a lot of times these foods are higher in calorie and higher in fat. So you just have to be cautious. So this is why it's good to mix up your meat sources, mix in some leaner proteins. Pork is a really good lean protein, even our grilled options instead of fried, because a lot of good complete animal proteins are high in calorie and high in fat. And then, of course, don't forget serving size. We talked about this in chapter 2, I believe. 1 serving size of meat is 3 ounces, the size of the palm of your hand, a deck of cards. We're likely going to eat more than 1 serving size. That's okay, but you just got to add it up over time, because it might add up more than you think, and then you're bringing in too much protein. Some differences here. Here we talk about grilled chicken versus KFC fried chicken breast. We do get more protein here in the fried chicken breast. I believe, though, partially because the serving size is bigger. But I just want to point out the fat. Okay, so the grilled options have much less fat. Now, in terms of the protein quality, we can actually give it a name. Protein Digestibility Correct Amino Acid Score, PDCAAS. Blah, blah, blah. You don't need to know this. I'm just putting it out there because there is a score. I didn't even give you a picture because you don't have to know it. There is a way we can more objectively score it, but you do not need to know this. So here we go. Putting it all together from carbohydrates, lipids, fat, and protein. We know the percentages. Somewhere between 45 and 65% of our diet should come from carbs. I'm really trying, everyone. These numbers I want to be ingrained in your head. Somewhere between 20 and 35% of our diet should come from fats, and we want to minimize our saturated fat, less than 10%. And then somewhere between 10 and 35% of our diet should come from protein. It is on the lower end, not because protein is less important, but because our body makes some protein for us. So we don't need to get as much through diet. It's good to have a variety of vegetable and meat sources and mix in some lean meats too. Here's an example of things that contain protein. It's not just meat and animal products. Look at the vegetables. Well, potatoes give us some protein. Most vegetables cooked, they give us some protein too, so it adds up, my friends. Okay, so I think it's important that we touch upon those people who are vegetarian or vegan. In other parts of the world, the diet is much more plant-based in the U.S. and more so occurring in other parts of the country because we're sharing this. It's more and more animal-based. But those who choose to eat little or no animal sources, they can meet their protein requirements. It's not that hard. If you don't try and you just eat, I don't know, Diet Coke and bagels, well, it's going to be hard. So it's just important to think about for those individuals. Variety of plant foods. Some people will choose to eat some meat alternatives. You don't necessarily have to, but you're better if you do. Nuts, soy, like tofu. There are different types of vegetarians. Let me go ahead one chapter. Okay. I would like you to know some of these. So let's point out a vegan. A vegan doesn't ingest any animal products at all. A true vegan doesn't even wear leather because that came from an animal. A true vegan doesn't eat Jell-O because it has gelatin in it that has been made from the remains of an animal. That's it for now. A lacto-vegetarian doesn't eat meat but does eat dairy. An ovo-vegetarian doesn't eat meat but does eat eggs. So there's different ways people can do it. Okay. This was the example I gave you in an earlier critical thinking assignment. This was a vegan. She was able to get really close to her protein intake, right? By having a lot of vegetables, nuts, right? Okay. Make sure we can review some of the basics of soy. Soy comes from the soybean. It is a high quality protein source. Okay, everyone gives tofu a bad name. I eat tofu. And yeah, it looks kind of gross sometimes, but the beauty of tofu is that it's a complete protein. It's low in fat, really good for you. And tofu takes up the flavor of whatever you put it in. I like to marinate my tofu, put it in the air fryer, it gets a nice crisp outer coating. And there's not just tofu that's hard packed. We see soy products in a lot of things. Here we go. I'm just trying to sell you, but these are probably not the right pictures to try and sell you on tofu, right? Here's some other meat alternatives. I'm not going to ask you about tempeh. Personally, I don't like tempeh as much. It's got a weird texture to me. Vegetarian diets do have a lot of benefits. They can lower overall calorie intake, fat intake. You're eating more vegetables. But, of course, the risks are that you can be deficient in certain things that come only or mostly from animal sources. We're going to talk about a lot of these when we get to the vitamins and mineral chapter. Here's a nice schematic. You don't have to know it. Okay. So I do want to talk about what can happen when we have too much protein. And these should be up arrows. Not only is protein difficult to break down because of that pesky nitrogen, not only are we not able to store a lot of protein. Well, when we try and get rid of protein, it's difficult to get rid of it. There's a whole chemical process where we got to remove the nitrogen, send it to the liver, do this, excrete it as urine. It's a pain in the butt. So too much protein over time can really stress our kidneys. Okay, so there is a legitimate concern of having a high protein diet over time because it really asks a lot of your kidneys. Of course, a lot of the animal protein sources are high in fat, particularly saturated fat. So a high fat diet over time can also lead to some heart disease, cardiovascular stuff. And let's not forget, if we are eating a lot of protein, particularly animal meat, it's taking space on our plate away from other things that we also need. Too little protein can actually lead to something, protein energy malnutrition. This is less common here in the United States. There is something called kwashiorkor. Maybe you see it particularly in like sub-Saharan Africa, where unfortunately children can be starving. Their bellies are actually bloated, and that's a complication of this, a severe deficiency of protein. You do not need to know that. Here are some pictures, but you do not need to know it. Okay, so we're just about done, folks. Let's go back to the beginning. Can we store protein? No. We store a little bit in the amino acid pools, but we can't put any in a storage shelf like we can carbs and lipids. What do we do with excess protein? Well, we try and store a little bit as the amino acid pools. We try and break it down, get rid of the excess through urine, but it's really hard because of the nitrogen. So if we keep bringing in more, our body will store it as fat. 2 servings of the Ultramet protein shake contains more protein than an average person needs in one day. Now, I did pick a protein supplement that was really high in protein. So 2 servings of this contain 84 grams of protein. That's a lot. Not all supplements have this high of a protein content, but some do. Read the label, folks. Someone who's under 50 pounds, a female, would require 56 grams. So for a 150-pound female who is somewhat active, that would be much more than they need. All right, folks, good job with protein. I will see you for the next chapter.